Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be working on question 5 from the coverage of question 2 for grade 11 elite. So, in the figure above, the line L is tangent to the graph of y equals 1 over x squared at point P. So, this line is a tangent line. It's touching the curve at point P with coordinates. So at B there is x coordinate w, and the y coordinate will be 1 over w squared, where w should be positive, bigger than 0, because look, it's in the first quadrant. Point Q has coordinates w and 0, so here we have w and 0 at point Q, and also there is the line L crosses the x-axis at point R with k and 0. So we have put all the givens on the graph. Find the value of k when w equals 3. So, in part A, we need to find the value of k when w equals 3. Now, how can I find a relation between w and k? Well, I will be using the tangent line, because the slope of line L, which is the tangent line, should equal to the derivative dy over dx at point what? At point P, at x equals w, at x equals w. So how do we find the slope of line L? By using what? The slope formula. So I can name this one as x1, y1, and this point as x2, y2. Now I can use 1 over w squared minus y1, which is 0, over x2, which is w, minus x1, which is k. This is equal to dy over dx. So we have y equals 1 over x squared. So y equals x to the power of minus 2. I raised it up, which is equal to what? We can now write dy over dx as minus 2x to the power of minus 3, which is minus 2 over x cubed. This is dy over dx. So minus 2 over x cubed, but we are going to substitute w instead of x, so that would be w cubed. So notice that we can now replace w with 3 as given in part A. So 1 over 3 squared minus 0 over 3 minus k equals minus 2 over 3 squared. Okay, solve it by the calculator. You get k equals, how much is k in part A? 4.59 over 2. So this is what you should get for part A. The value of k is 9 over 2. Okay, what we have done here is the derivative. What we have done here is the derivative. Okay, so part B, for all w is bigger than 0, find k in terms of w. We want to find a relation between what? We want to find a relation between w and k. Okay, we will use what we found in part A. Okay, so let's try to isolate k, because we need to find k in terms of w. So we've got 1 over w squared minus 0, I'm not going to write it, over w minus k equals minus 2 over, that is w cubed. So there is a mistake in the previous part. Let's go back and fix it. This should be cubed, this should be cubed, right? So k will not change, it's 9 over 2. Okay, so please excuse this little mistake. I should have written cubed instead of squared. Okay, so now we are going to isolate k by using the cross multiplication. 1 over w squared times w cubed is just w equals minus 2 times w, it's minus 2w, minus 2 times minus k is plus 2k. Get this to the other side, w plus 2w will be 3w equals 2k, divide by 2, divide by 2. So you've got w, sorry, we are isolating k, not w. Let's erase it. You should get k equals 3 over 2w. This is the value of k in terms of w. Now, part C says, suppose that w is increasing at a constant rate. So this is w or dw over dt, which is equal to 7. When w is equal to 5, what is the rate of change of k with respect to time? So we are looking for dk over dt. So to find that, you need to find a relation between w and k, which is the answer of part B. So you just need to differentiate what you got here. So dk over dt equals 3 over 2, it's a coefficient, leave it, dw over dt. So you need dk over dt equals 3 over 2 times dw over dt is given, which is 7, so that is 21 over 2. This is dk over dk over dt, which is going to be measured in units per the time is measured in second. Yes, per second. Okay, so the last part says, suppose that w is increasing at a constant rate of 7 units per second. We are given dw over dt. W is equal to 5. What is the rate of change of the area of triangle PQR with respect to time? So the question is asking for the rate of change of the area of this triangle. So let's graph the triangle down here. This is part D. This is the triangle, right? This point is w and 1 over w squared. This point is w and 0. And this point is k and 0. Okay? So this is what? This is the base and this is the height. I know that the area is given by half times the base times the height. So we've got half. Now the base will be the difference between the 2 points. It's k minus w. K minus w. This is the base. And the height of this triangle, it's the y coordinate of the upper vertex, which is 1 over w squared. Now, we can eliminate k here by substituting what we got in part B. What we got in part B is here, this one. We can use it, we can replace it with k here. So the area equals half. Instead of k, you can write 3 over 2w minus w times 1 over w squared. So what I'm doing here is that I just replaced k with this amount. Now you can simplify because now everything is written in terms of a. So this is going to be what? 1 over 4. And on top you have W and 1 over W, because W will cancel with the square. Now, to find the derivative dA over dt is equal to 1 over 4 is coefficient. The derivative of 1 over W is negative 1 over W squared times dW over dt. Now, dA over dt at that moment would be negative 1 over 4 times 1 over W squared, which is a 25, times dW over dt, which is 7. This is negative 0.07 unit squared, I guess. Yeah, unit squared per second. This is the 5th question of the second file. I wish you all the best.